Good evening, everyone. Good evening, good evening, good evening. Welcome, 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 welcome. How is everyone? Are you guys enjoying your phenomenal Friday? Yes, we are coining Phenomenal Friday today. All right, so guys, you already know what's going on. We are learning about pre-calculus. We are winding down our pre-calculus week for those who want advanced learning or our high schoolers that are preparing for pre-calculus. Just key concepts, basic necessities that you will need in order to succeed in pre-calculus. So you guys know the drill. Hit the like button, hit the share button, hit all the good buttons to let me know that you can hear me so we can get started. Other than that, thank you for tuning in. Happy Friday. Awesome sauce. Thank you for hitting that like and heart button. Let's get started. All right, you guys, going to touch on a few key subjects. And then if you have any questions, of course, you know to comment them below. I am here to help. Let's get to it. So today, first subject we are going to touch on, determine if your function is an even or odd function from the graph. So, or on the graph. So, say for instance, you have x squared. To determine whether or not it's even or odd, what you would do is substitute a negative or inverse x squared and a negative x. And so if the negative x comes out to be the same, which it should because we put the negative x in parentheses, if it comes out the same equation, then if it comes out as the same equation, then it's considered an even equation. Now, expand this for a moment. Now, say for instance, you have x to the third, and you place a negative x for the function. Well, negative x to the third is negative x to the third. And if I pull my negative out, or my negative 1, that will give me the inverse of x to the third. So if there's an inverse, if I pull out the negative and it goes back to the original problem, then my function is odd. Now, if it does not go back to the original problem, or if I pull out the negative and it doesn't come back to the original problem, it will be considered neither. So to determine if you are working with an even or an odd function, evens, they return to the original problem. Odds are the inverse of the original problem once you pull out a negative 1. And here are some examples. Say you have 3 x to the 4th minus 5 x squared plus 10. Now, to determine if it's even or odd, I'm going to place a negative x for all my x's. Now, of course, 3 negative x to the 4th, that gives me x to the 4th, because anything to an even power is going to make it positive. Anything to an odd root or odd power is going to make it negative, especially if you're raising a negative to the 3rd, 5th, or 7th power. So then I have minus, you have 3x to the 4th minus negative x squared, that is x squared. Well, correction, because I did forget something, you guys, and that was my 5. Sorry about that. So minus 5, and of course, negative x squared is x squared plus 10. So, as you can see, when I plugged in my negative x for x, I was able to get back to the original problem. Since I was able to get back to the original problem without pulling a negative 1, the equation is considered even. Here's another example. You have 4 x to the 3rd minus 7x. And of course, you plug in a negative x. And that brings me 4 negative x to the 3rd. Negative 7 times a negative x, that's plus 7x. And of course, that gives me negative 4x to the 3rd plus 7x. Now, if I pull out a negative 1, or pull out the negative, or factor out the negative, then that will make this 4x to the 3rd and minus 7x. So we do or are able to go back to the original problem, but we first had to pull out a negative 1 or factor out the negative sign. So by doing a factoring out of the negative, I have determined that my function is odd. Any questions on identifying even or odd functions? All right, moving on. All right, I'm going to open up my graph page to show you the different types of graphs you're going to be using and seeing for precalculus. All right, sharing the screen now. All right, you guys, as you can see, I have a handy dandy graphing page or graphing calculator. I'm using this particular one. Desmos is free and it allows you to see and interact and do all types of graphs so you know what your graph will look like once you graph it. Virtually, or if you have to graph it on the paper, make sure you can verify it, verify how it looks with Desmos as well. So, first graph we are going to look at is a linear function. Linear function is when y equals mx plus b, or when y equals x. As you can see, linear function, it goes when it's positive from left to right, it rises. When it's negative, it's falling from left to right. Now, with linear functions, most of the time you'll see them either with just x or you'll see them rise and fall based on the y-intercept. So if you are wanting to move the graph 2 units up, you would do x plus 2. As you can see, I shifted up 2 units. Now, if I want to move my graph down, I do minus 2. And that'll shift it down 2 units. See that? Any questions on the linear function? Next function we have is the constant function. Constant function simply means you have a horizontal line where y equals a number. As you can see, it's a horizontal line going straight across, and it doesn't go up, it doesn't go down, it just equals a number. This is called a constant function. Next, we have square function. Square function is the beginning of all even functions or common even functions. And with this particular function, it allows you to see that both tails go up when it's positive, or both tails go down when it's negative. Next, we have the cubic function, which is the beginning, which technically the beginning function of odd functions is y equals x, but to see the definition of the rest of the odd functions, that starts with the cube function. So basically, the cube function is the bit version of the linear function. And a lot of odd functions will look exactly like this. So whenever you're dealing with the odd functions or cubic functions, know that from left to right, it'll begin a rising pattern when it's positive. And when it's negative, it has a falling pattern from left to right. Next, we have the reciprocal function, which typically is a number over a function, whether it's x plus 2 is usually a fraction. And the reciprocal function, if as you can see, has two bending graphs, one pointing up and one pointing down. And that's only if it's positive. If it's negative, of course, it flips, where instead of being in quadrant 1 and 3, we are in quadrant 2 and 4. Next, you will see piecewise functions. Piecewise functions typically are in pieces. And so with those, you have to make sure that you set the correct parameters. Otherwise, it will not graph correctly. Sorry about that. One moment. There we go. That's what I want. Okay, so as you can see, you have the -1 is -1 is less than or equal to x, which is less than 1. That is part of your piecewise. So that means this part would be solid, and this part of the graph would be dashed, meaning it's not included. And so when graphing a piecewise function, know that usually this circle would be open and this circle will be closed and this circle would be open based on the graph. So if I zoom in, what it really should look like is where you have the circle closed over -1, 2, and then the circle open at 1, 0, while graphing this part of the graph for the piecewise function. Then, of course, you have where y equals 2. And with y equals 2, where you see where x equals 1, that means you would have a closed circle over x equals 1. Then for x to the second power, okay, still won't let me do that. It used to be where you could, but that's okay. Okay, so this part and this part and this part. So where x is greater than 1, you will graph this part starting at 1, 1, and then you will graph all of that. And you will also make sure that the circle where x is greater than 1 is open for the x squared function. So First graph, -1 and 2, closed circle. You graph all the way till you get to 0, 1 with an open circle. Okay. After that, you graph y equals 2, where at 1, 2, you would have a closed circle because x would equal 2. X will equal 1. So where x is equal 1 on the graph of y equals 2, all you have to do is put a dot. That dot would be 1, 2. After you've placed your dot, then you can graph the x squared function where x is greater than 1, starting at 1, 1 to infinity, which would be this way. And you must make sure the circle is open. That way it's continuous and it does not close off the graph. Put it all together. And you should have a graph that has y equals -x plus 1 from here to here with a dot here and an open circle and graph of x squared going upward here. Any questions on piecewise functions? All right, moving on to the next subject matter. And that would include translation. So in order to do translation, we are going to go back to our Desmos graph. Now, translation is basically taking the original graph and moving it across the graph. How do you take a graph and move it across the graph? Well, you have it where it will shift up, it'll shift down, it'll shift left, it will shift right, it will flip up or down, depending if it's negative or positive, and whether it will stretch or shrink based on the fraction outside of the graph. So, first thing we are going to cover is shifting up. And the best graph to do this with is an x squared graph. So, say for instance, you have x to the second power. And you want to take x to the second power and you want to move it up 2 units. To move it up 2 units, you'll simply say plus 2. See that? Original graph is x squared. X squared starts at the origin of 0, 0. To make the graph go up 2 units, I put plus 2. Next, we have vertical. Now, also keep in mind, these are called vertical shifts. So vertical shifts mean you're going to go up or you're going to go down. So plus makes you go up, minus makes you go down. These are considered the vertical shifts of a graph, which cause translation. Next, we have horizontal shifts. Horizontal shifts will let me know whether or not I'm going to the left or to the right. Now, horizontal shifts are different than vertical shifts. Vertical shifts are self-explanatory. Plus go up, negative goes down. Well, for the vertical shift to go to the left, say you want to go to the left 3 units, you would do plus 3. Reason why is because remember the vertex form of the equations that we covered? Well, if you remember, anything subtracted from h, anything subtracted from x shifts the graph to the left, to the right, and then anything added to x shifts it to the left. And so that's based off of the h, which is your vertex. And that shifts it, the original h will shift it to the left or to the right. In other words, original equation looks like this. Ooh, that's even better. So now, if your h is negative, it'll shift to the left. If your h is positive, it's going to shift to the right. So in order for it to be in order for you to shift to the left, that means that's a minus negative h. So if I'm shifting to the left, x minus 2 makes that x plus 2 raised to the second power. See that? So always remember, plus inside a parenthesis shifts to the left, minus inside a parenthesis shifts to the. This is called horizontal shifts. Horizontals are inside parentheses. Plus shifts you to the left. Minus is going to shift you to the right. Any questions on horizontal shifts? Next, we have vertical compression or stretch. Now, when dealing with vertical stretch, know that vertical stretch means your number, the number on the the first number or the coefficient is greater than 1. So in order for it to be a vertical stretch, your coefficient, which for me is 2, will have to be greater than 1. Now, if you want your graph to be compressed or shrink, then your coefficient of the graph must be between 0 and 1. So for this, I would do 1/2 x squared. And as you can see, it compressed or shrunk or it expanded outward. So coefficients from between 0 and 1 are vertical compressions. Coefficients greater than 1 are vertical stretches. And of course, if it equals 1, it's the original equation. Any questions on the compressions or stretches? Any questions on translations as a whole? All right. Next, we have our reflections. Reflections are based off of the axis or the origin. So now, say for instance, you have x squared. Reflection on the x-axis means it rotated up then down. So x-axis reflection means it's going to rotate against the x-axis. That means your x's are going to stay the same, but if you notice, y's become negative. So reflection on the x-axis means your y's, your original y's, become negative. So where 2 is 4 from the original graph, the reflection is 2 negative 4. So in order to have a reflection of the x-axis, of course, you change it from negative to positive. All right, reflection of the y-axis. What does that look like? The best way to show that would be with a square root function. So to reflect the square root function on the y-axis, all I would have to do is turn the inside negative. As you can see, we were able to reflect on the y-axis. Any questions on reflection? Well, you guys, that's really all I had to cover for today. I Precalculus is really a repeat of Algebra 1, Algebra 2 with a little bit of geometry. The main goal of Precalculus is the trig functions, which is what we covered Tuesday and Wednesday. So, if you have any questions, now would be the time because guess what? It's our live tutoring session. Questions, please comment them below because you know Miss Chris is always here to help. Other than that, thank you for tuning in and have a phenomenal Friday. Hello, 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 and welcome. And thank you for tuning in for the live tutoring session. We have already covered our pre-calculus portion. If you would like to review what we've done, you can click on the YouTube link, and the YouTube link will direct you to the immediate live, which will allow you to review covered for today. Other than that, if you have any math questions, any of them at all, please comment them below because guess what? Miss Chris is here to help you understand and explore mathematics. Other than that, I hope you're having a phenomenal Friday and thank you for tuning in. Well, you guys, if there are no questions, we are going to go ahead and end our live. I hope you guys had a wonderful Friday. Of course, if you have any questions outside of the live and you need to reach me, you can inbox me, you can IM me, and you can DM me on all of my social media platform under Krishan Mechanico or Mathematics for You Tutorial Services. C can be found on Facebook, YouTube, and Instagram. Also, you can text me at 205 542 5062, 205 542 5062. Again, this has been a wonderful, wonderful journey with you guys. I will see you tomorrow in the morning at 8. We're going to wrap up Precalculus. And then once we're done with Precalculus, we are done with our program. Glad you guys were able to tune in and learn all the key basics we need to work together. Of course, you can watch all the saved videos on YouTube for those who are looking for the saved videos. The link for the YouTube page is in the description below. Click it, review, relax, rewind, and release. I'm glad you guys enjoyed your Friday. Glad you took time to spend a little bit of your Friday with me just to learn a good piece of math as we continue to explore together. Also, starts 22nd, we will do live tutoring sessions since kids are starting back school. If I'm not mistaken, a lot of kids are starting back around the 18th, 19th. And so I know for Alabama, a lot of kids are starting back on the 24th and the 28th. So again, if you have any questions, you know where to find me. I will be here on Saturdays. I will post my official schedule Saturdays on August 15th. Other than that, I hope you've had a fantastic day. Thank you for tuning in. This is Miss Chris of Mathematics for You Tutorial Services, LLC, where we are changing mindsets one problem at a time. Have a good evening.